complex queries. C.1, correlated nested queries. So last time we learned correlated queries. Oh, sorry, last time we learned the nested queries. But this time, correlated, because for the nested queries, we have inner queries and outer queries. But when we look at the relationship between these two levels, you can see there is still one important thing we need to consider. That's the correlationship. Yeah. So, all right, so let's look at the definition first. What kind of nested queries we call correlated queries? Yeah. Definition. Yeah. Whenever a condition in the where clause of a nested query references some attribute of a relation declared in the outer query, the two queries are said to be correlated. It's a long sentence. Yeah. So let me describe it. All right. Yeah. We have two levels. Yeah. We have here outer query. This is outer query. All right. Yeah. Outer. Okay. Outer. Then inner. Okay. Outer, inner. All right. When you have this structure, it is not necessarily correlated. Yeah. Because when you describe a table in the outer query, then after getting into inner query, you do not need to reference anything in outer query. Yeah. When that happens, we do not call it correlated. Yeah. So inner query, outer query, completely independent. There is no correlationship. All right. But there is a special nested query. So in the outer query, you have some attribute, right? Yeah, here. Yeah. We have some attribute. But this attribute is references inside inner query. In the inner query, when we describe some selection condition, we use this outer attribute. Yeah. In a select condition. If the query has this structure, so we call it correlated nested queries. This type of queries usually harder to understand than non-correlated nested queries. Because completely independent. Okay, yeah. So you just look at each query in its own way. You do not need to worry about the correlationship. Yeah. But this type, yeah, you need to think about when you try to understand the logic. You need to really try to understand that correlation part well. Yeah. So that'll make the understanding a little harder. Okay, yeah. Yeah. But many complex queries have the structure. Yeah. So we have to get used to it. Yeah. All right. Understand correlated queries. Here, there is a typical way we use to understand correlated nested queries. All right. So this way, yeah. Actually, this way, we are quite familiar with, similar to the way we handle for loops. in our programming languages for loops, while loops. Yeah. The way we use in our understanding, same way. Yeah. We can understand a correlated query better by considering that the nested query is evaluated once for each tuple or combination of tuples in the outer query. Yeah. Now it's another long sentence. Yeah. Here, you just imagine each tuple. Yeah. All right. In the outer query, think about in the outer query. So this is outer query. Outer query, you supposed to have a table. All right. Outer query targeting table. Yeah. So this is, the target table. Yeah. The target table, you need to go through all the tuples, all the rows, right? You need to do processing, go through from beginning to end, right? Yeah. Yeah. All of them. Yeah. And similar to our for loop structure, you need to do iterations, right? One by one. Yeah. So every time you have a pointer or iterator, yeah, some special variable, iterator, pointing to the current tuple. Here, this is a current tuple. Okay, yeah. When you consider the current tuple, then this current tuple is carried in this inner tuple. Yeah. Yeah, because you need to take this current tuple that is referenced in the inner query. Yeah. So this kind of relationship. Yeah. Here, that's the way we understand. Yeah, but when you carry this current tuple into the inner query, you fix it. All right. You fix it. Fix this tuple. All right. Yeah, you fix it. All right. Because that is in the current iteration. Now, so this is the current iteration. Okay. Yeah. When you look at the current iteration, you do not look at, other tuples, just this one, the current one, and you fix it. Yeah. So when you doing the whole inner query, yeah, you treat the current tuple as a fixed value. With this understanding, then you understand the inner query. Yeah. Yeah. So that's the way this long sentence tells us. Okay. Yeah. All right. So let me read the sentence again. We can understand a correlated query better by considering that the nested query is evaluated once for each tuple. Yeah. In the outer query. Yeah. In the outer query once. Yeah. So each tuple once. Yeah. But here I expanded. Yeah. Yeah. Because from this sentence you cannot see this much meaning. Yeah. So I expanded. Yeah. So once, although once, but after we take that tuple, we need to carry it into the inner query. Yeah. And when we understand the inner query, we need to fix it. Yeah. We do not change its value when we try to understand the inner query. Yeah. Treat it as a constant. Yeah. In the outer query, that is a variable, because we need to use that variable to go through all the tuples in the outer query. But when we get into the inner query, we treat it as a constant. Yeah. So we do not change it until we complete the whole query in the inner query. Then we change to the next one, next tuple. Yeah. So that's the, that's, you can understand that this kind of logic mechanism as in the nested for loops. So similar to your understanding of nested for loops, right? So you have an outer for loop and an inner for loop. Yeah. Outer for loop, so you have a counting variable. Suppose, right? Yeah, iterator counting variable. So you take it into your inner for loop that way. All right, yeah. Now, then special operators, any and some in combined operators. Yeah. We may use some simple operators in our queries. Here, equal any or equal some operator, special equal any. Yeah, this operator, its name is called equal any, combined. Yeah, so here we call it combined operator. So what do we mean combined operator? Two or more, here typically two different operators, we put them together to form a new operator. So here, equal is one operator, right? Any, another operator. Equal, any, we put them together, so we get a new operator. Yeah. So just based on the meaning, you can understand equal any of the tuple in the multiset. Yeah, here. Actually, these equal any, equal some, equivalent, with different names, but the same thing. Yeah, equal any, equal some. Yeah, from the English, so you can figure, same meaning. Yeah, but here it is equivalent to in operator. We just learned last time in. Yeah, in. Yeah, one element is in a set. That relationship. That's the same thing as equal any. One element equals any of the just one of the elements in a given set. The same thing. Yeah, here, usually we like to use the in operator. So we prefer in operator. Yeah, but we need to know, if other people, if they use equal any or even equal some, so its meaning. Yeah. Just the same thing as the in operator. Yeah. Yeah, so that's enough. So for ourselves, so we, most of the time we use the in operator. Okay, yeah. All right. But there are other combinations we can consider. Operators other than equal. Yeah, because you have other than equal, you have greater than, less than. You can use them in the combined operator way. That can be combined with any or some and all. Yeah. Another possible case, we can use all. Yeah. All. all elements in a given set or multi-set. Yeah. Yeah. And we can use, these different operators combined with any, some, all. Okay, yeah, yeah. But this way, here, this way, these operators combine with any, because any sum equivalent. Yeah, so here we just use any or all, but combine with any, if you use greater than, other operators that will be different from equal any, so different from any. Yes, because only when any is combined with equal, then that's the same thing as the any. But for other combination types, then it's different. So still, we have chances we may need to combine operators with this any operator. Any. Okay, yeah. All right. Also, all here, all, yeah. All elements in a given set. Yeah. So let's use an example to understand this this type of combined operators. Yeah. Look at this example. In this example, we select those employees. Yeah. Look at our selection condition, select condition. This employee needs to satisfy this condition. Its salary, the salary value should be greater than all. Yeah. Combined operator greater than all. All the salary numbers in those employees in the department 5. That condition. Now, here, so you can see greater than all. So you understand the meaning. Yeah, this employee who has the salary greater than the salary of any employee in department 5. Yeah. Here you can see this greater than operator, greater than all operator, you can see, you can compare with another similar case, maximum. Yeah. Later we will talk about, aggregate functions, max functions, maximum salary. Yeah. Think about maximum salary. Yeah, actually, this employee has the salary greater than the maximum salary number of all the employees in department 5. Yeah, but not equal. Yeah, greater than here, not equal. Yeah, so you need to, these two ways, yeah, a little different. Yeah. So when you do understanding, yeah, try to see the different meaning. Yeah. Max and greater than all. Okay. Yeah. All right. Next, aggregate functions. This part also, we used a lot. Okay, we use aggregate functions a lot. Yeah. So let's, look at the common properties. Yeah. Aggregate functions. Yeah. First, we use these aggregate functions to summarize information from multiple tables into a single tuple summary. Yeah. The returned result is a single tuple summary, yeah. Just one row. So you apply those aggregate functions on a whole table in certain way, and it returns one tuple result. Okay, yeah. So many times, just the one number, it returns, the function returns one number. Okay, yeah. Although, yeah, because your aggregate function could be used with other attributes together, so that won't be one number. Yeah, yeah. Its function value is one number, but you apply this function on the whole table in a special way, so then the return result could be different. Yeah, so we will, yeah. All right. First, let's look at a simple example first. All right. These are the commonly used aggregate functions. Count the number of rows in a table. Sum, yeah. You apply sum function on a particular attribute. Column, yeah. Sum, yeah. In a table. Yeah. You need to specify, yeah, which attribute you want to apply this function. Yeah. Max also, max, min, average. You need to specify which column you want to apply these functions. For count, yeah, count is a little different from the remaining aggregate functions. Those remaining, the column, the attribute, important. But for this count, you can specify attribute. Yeah. So that's one option. Yeah. You can specify one attribute you want to apply. Yeah. But there is another version. You do not need to specify which column you want to apply, because you count the number of rows. You count the number of rows in a given table. Yeah. In that case, you use that star. You don't need to specify which field you want to count against. Yeah, yeah, because you just count the number of rows in a table. But we will see later, we will see one example using the star way and using the attribute name. Yeah. These two different ways have some difference, have some important difference. So we will see, because that difference is related to the null value. Think about that, null value. Okay, yeah. Null value. Yeah. Because the behavior of these two ways, the star way and the attribute way, they treat the null value differently. Yeah. So we will see, understand that part through one example. We will see the difference. Yeah. Okay. All right. Grouping. Yeah. Another important concept. Grouping. Yeah. When you apply aggregate functions, many times you need to specify the grouping rules. What grouping rules you want to define? Okay, yeah. Grouping the rows or tuples in a given table. Yeah, so first, let's look at the definition first. Yeah. Grouping is used to create subgroups of tuples before summarization. Yeah. Here, let me draw a diagram. Yeah. So why? Yeah. Actually, this way is very useful. Yeah. So, yeah. So let me describe this grouping way. Yeah. All right. Suppose we have a table like this. Okay, yeah. Many rows inside this table. Yeah. All right. So this table, we want to apply some aggregate function. Okay. Yeah. All right. Yeah. But when we apply, we need to use a special way to apply. Okay. Yeah. We do not. Yeah. So here. Yeah. Before this grouping, when we apply on the whole table. We apply aggregate functions on the whole table. All right. Now, another different way to apply. Not the whole table. No. We divide this table into many subgroups. Okay. All right. Subgroup 1, subgroup 2, many subgroups. Yeah. Then the aggregate function is apply aggregate function on each subgroup. Okay. For each subgroup, you apply aggregate function, you get a number. Okay. The second subgroup, you apply this aggregate function to get second number and so on. Okay. Yeah. So each subgroup, you get one number. Yeah. Yeah. We need to, many times we need to use this way. Okay. Yeah. So then the grouping, the subgroup definition is very important. How to define subgroups. So that's important. Yeah. Yeah. So this, when we use the aggregate functions in this way, yeah, we can do a lot of things. Yeah. So we need this special way. Yeah. And you can see this way actually is more general, because the non-grouping way, you can treat the whole table as one group, right? Yeah. So non-grouping way, whole table, because you do not define subgroups, then the whole table is treated as one group. So you apply each aggregate function on the whole table, that group. Yep. Yep. All right. And how to do it? How to define some group by? Yeah, group by clause. That's the place you define your subgroups. Very simple. Yeah. So we will see how to define subgroups. Yeah. Example: a correlated nested query with an aggregate function. Okay. Yeah. All right. So let's look at this query question. Retrieve the names of all employees who have 2 or more dependents. You have different ways to write this query. All right. First, older way. Yeah. Older way. Yeah. Older way, we do not use aggregate function. Yeah. So we can use other way, other different functions, different operators. Yeah. So let's look at this way, not a unique way. Yeah, this not a unique operator. Unique, unique, right? Yeah. So this unique function, the tuples in this table must be unique function. Okay. Yeah. If all the tuples are unique, it returns true. Otherwise, false. The unique function. Not unique, the opposite way. Okay. So not unique, it's true. If unique, it's false. Okay, yeah, not unique, it's true. Yeah. All right, so here, select the names of the employee. Yeah. Then in the inner query, not unique. So you list the dependent information in the outer query. Yeah, because outer query, the ESSN, this attribute in the outer query is carried into, oh, sorry, not ESSN, SSN, right? SSN of the outer query is carried into this inner query here, right here, and fix it, okay? Yeah. So because when you change ESSN, you fix that E.SSN. Yeah. Yeah. So you fix it here, but you go through all the ESN in the inner query. Yeah. If equals, yeah, those two values are equal, then you select. Okay, you select that tuple. Yeah. But here, not unique. Actually, I think this star thing has some problem. Yeah. Think about it. Yeah. Here, the star thing has some problem. So what's the problem? Because when we put the star there, that's the meaning is that whole tuple, right? That whole tuple. The whole tuple means it contains all the attributes in the tuple. Yeah. Then for this dependent table, if you select the whole tuple, that may not be unique. So for one employee, because different dependents, they have different first names. Yeah. Whole tuple, because you have the, birth dates. They have different birth dates, birth dates. So if you consider whole tuples, they're unique. The values are unique. So your not a unique function won't return true if one employee has 2 or more children. Yeah. So that means this way actually not quite right. Yeah. So we should not put that star there. We should put that ESSN. Yes, not a unique, but here we only look at the ESSN part. If an employee has more than one child, then that ESN will be repeated multiple times. Then we apply the not unique function. Yeah, we will see, not unique, it will be true because we will see this ESN multiple times, not unique. Yeah, yeah. But if you put that star, the whole tuple, that may not be unique. So that difference is important. So this example tells us when you use that star thing, you should be very careful. You need to consider the specific meaning of that star. Yeah. You could use it in a wrong way. Yeah. Here, yeah. That is the wrong way. Yeah. Okay. Yeah. So you should specify the attribute you want to look at clearly here. Yeah. Not in a vague way. Yeah. Not in a vague way. In a clear way. Yeah. This ESSM way. Okay. Yeah. That's all the way, but here, after we learn the aggregate functions, so we can use the aggregate function way to do it. Okay, so the new way, yeah, the same thing, but in our inner query, we apply that count function. This function is applied on the whole tuple, that star whole tuple, but it's fine because when we specify the condition, select condition, and we fix SSM, then we may have multiple tuples with the same at ESSM. If this employee has more than one dependent, here, not just children, dependent, because including spouse, here, because we only talk about dependents, not necessarily children, including spouse, okay, So this ESSM, when it is equal to SSN, then we count the number of rows. Here you only count. Here you do not need to specify, which attribute. So you just count because you will get a number, specific number of rows that satisfy this condition. So when this number greater than or equal to 2, number 2, then not unique, 2 or more. So here you have 2 versions. All the way, you do not need to use aggregate function. And the new way, you use aggregate function. Here we can you can compare these 2 ways. Which way in general is better? Actually, you can see the aggregate function way is better. Why? So here we do not compare the performance. Performance, we can say, almost the same performance. All right. But if we compare the power of the functions, so you can see aggregate function way more powerful. Why? Because think about it. If it's not 2 or more, it's 3 or more, 4 or more, right? Then you just change a number here. But not unique, you cannot separate, right? 2 or more, 3 or more, 4 or more, you cannot separate using not unique. They're all not unique. So that means that way is not that powerful. All right. Many things you cannot do. You cannot distinguish if you just use that function. Okay. All right. So from this simple example, you can see when we use aggregate functions, we can describe many of our business needs well. Okay. Better. All right. Max and min functions, maximum, minimum functions. So let's look at the basic rules of these 2 aggregate functions. Basic properties. First, we apply these 2 aggregate functions on numeric values. Then that's easy. Numeric values, we can find the maximum, minimum easily. So that's the first case, the simple case. All right. Then, other than that, non-numeric values can also be used with attributes that have non-numeric domains if the domain values have a total order among one another. Total order. I explained this concept before. Here, we need to use this concept again. So when when we apply these two aggregate functions, max, min, yeah. All right, so here, the total order and the partial order, these two concepts, I explained before. Yeah, here, just explicitly, total order, every two elements can be compared in one of the three cases, equal, less than, greater than. Yeah. But partial order, you only need to have that transitivity property. Okay. If that is true, but not necessary every two elements you can compare with these one of the three operators. Yeah. If A greater than B and B greater than C, then A greater than C, the transitivity property must hold. Yeah. It is not necessary that any two elements can be compared. That's the partial order. Okay, yeah. But here, when you apply max and min functions, you require this total order on the domain you apply. Otherwise, it does not make sense. What is the maximum if you cannot compare? For some of the values, if you cannot do the comparison, it cannot return any value. Maximum value, minimum value. All right, yeah. So that's pretty straightforward. Yeah. But fortunately, most of the time we have the total order. Yeah. String values, alphabetic order, that's a total order. Date of birth, dates. Yeah, dates. We have an order defined. Yeah. And some certain domains. Yeah. Yeah. All right. Then now we want to understand the grouping a little more. Partition for grouping. Yeah. That grouping. Yeah. Because when we define subgroups, sometimes it could be a little complicated. Yeah. So we need to understand the grouping concept. Yeah. All right. Yeah. Partition concept for grouping. How to define subgroups? We use this partition concept. Partition concept comes from math, set theory. There is a partition concept. So let us borrow the partition definition from math set theory. Yeah. Partition a relation. Yeah. Here we apply some partition on a relation, similar to in math we apply partition on a set. So relation corresponds to a set, yeah, or multiset. Yeah, because the general case, multiset. Yeah. All right. Yeah. So what is the partition in the set? In the set theory, yeah, the partition means, yeah, it has several properties. In order to have a partition, you need to get these three properties for a partition. So yeah, let's look at one by one. Yeah. The first property, a partition must cover the whole set. Must cover the whole set if you have a partition. Yeah. Actually, partition. Yeah. Partition. Yeah, because here you do not have the basic understanding of a partition. Yeah. So in a set, partition, yeah, is you can understand this way. So union of several subsets. We call it partition. Okay, union. Some special way of union, but this union, yeah, definitely this union, not just the arbitrary union with those three properties. Yeah, so here I described three properties. Not arbitrary union. The first property covering the whole set, that's the property. So this union must be equal to the whole set. The union of the subsets equals the whole set. You do not miss anyone. This union does not miss any element in the original set. Okay, yeah, so the first property. Second property, non-overlapping property. The intersection of any two sets in this partition is not empty. Yeah, non-empty. Yeah, so no overlap. Yeah. If I draw diagram, so suppose this is the whole set. Okay, yeah, so whole set. Then you have partition. So you define partition. Subset 1, subset 2, subset 3, subset, and also in the middle. Yeah, no non-overlapping. All right, yeah, so here for two different subsets, there is no overlapping. That requirement, the second requirement. Okay, yeah. The third requirement, non-empty. Non-empty. So what's that? None of the subsets is empty. Yeah. You should not include, yeah, for example, for one subset, it happens to be empty, then you should remove it from the partition, right? Why you include an empty set? It does not make sense. Okay. So each subset in the partition must be non-empty. Okay, then you can put it in the partition. Otherwise, you take away. You take any empty subset away from the partition. You simplify it, right? You make it simpler. Yeah. So if you get a group of subsets in this way, then that group of subsets form a partition of a set. Yeah. Here, that's the original meaning in math set theory, partition. But here, we borrow this meaning. Okay. Yeah. We need to modify slightly because here we consider multiset. Yeah, multiset. Okay. Yeah. It is a little complicated, multiset. Yeah. But yeah, we need to define a partition in a table. Subgroups. Yeah. Each subset. So that's our subgroup concept. Okay. Yeah. All right. Groups and grouping attributes. How do we define groups? We use attributes. We use grouping attributes to define subgroups. Yeah, all right. Partition a relation into non-overlapping groups of tuples. Yeah. So each group, a set of tuples, or a multiset of tuples. Okay, yeah. How to partition a relation? Yeah. Each group will consist of the tuples that have the same values of some attributes. Yeah. Sometimes you use one attribute to define a group. So when you use one attribute, so each attribute value you can use to define a subgroup. But sometimes you may need to use multiple attributes. to define subgroups. Okay, yeah. So called the grouping attributes. Yeah. All right, yeah. So group by, remember, we use the group by clause. After that group by clause, so you list your attributes, your grouping attributes. Okay, so then the tuple value of your attributes, tuple value. So if you have more than one, yeah, tuple values, each tuple value defines a subgroup. Okay, yeah, all right. All right. Example. So look at this one, yeah, simple one, yeah. Select Dino department number. Yeah. Then you apply two aggregate functions. The first one, count. You count the number of tuples in each subgroup. Okay, each subgroup. Also, you second aggregate function, you calculate average salary number for each subgroup. How to define subgroups? From employee group by department number. Here you can see each department number you treat it as one subgroup. So now, first, you count the number of employees in each department. So each department, you have one number, okay? After that, you calculate average salary number for that department. Yeah, so then you return a list of tuples. Each tuple, you have the department number, then the number of employees. After that, the average salary number. Pretty convenient. Yeah, think about it. Yeah. So pretty natural. So we need this kind of information in our real world business needs, right? Yeah, yeah. All right. Here, the grouping attribute, only one department number is used as the grouping attribute. Yeah, so very simple. All right, yeah. Null value in the grouping attribute. Because some of the attribute values may have the null value. When you apply aggregate functions on attributes containing the null value, how do you treat those special values? Yeah. All right. So let's look at the rule. Yeah. If nulls exist in the grouping attribute, yeah, then a separate group, yes, a special separate group, yeah, separate from those with usual values, normal values. Yeah. Normal values, we know each normal value defines a group. Yeah. But here, this null value, we put all those tuples with null value for a particular attribute in one group. Just one group. Yeah. Is created for all tuples with a null value in the grouping attribute. That's just one group. Okay. Yeah. Not different groups, one group. Yeah. That's the rule. Yeah. All right. Yeah. Question. Yeah. Here, a query example. How many employees are supervised by each supervisor? Because we know the supervisor attribute field may have null values in our company database, in the employee table. there are a certain number of employees who do not have supervisors. Okay, yeah. Who do not have supervisors. So their supervisor SSM null value. Yeah. So we need to consider those cases. All right. So look at this query statement. Select count SSM. Count SSM. SSM, we know SSM, all employees have SSM, right? Yeah. So we won't have any problem count SSM. All employees have SSM. Okay. Yeah. From employee group by super underscore SSM. So when we define subgroups, we use the super underscore SSM. But some of the employees, their super underscore SM have the null value. So those employees we put in one group, one single group, separated from other normal groups. Yeah. So the result is this. Yeah. Result, you see, yeah. 7, the first one, the first group, that's for the null group. Yeah. There are 7 employees. There are 7 employees whose super underscore SM take the null value. The remaining normal values. Yeah. So you see the remaining, each value has its own subgroup. So then we count number of tuples in the individual subgroups. Okay, yeah. But yeah, so this 7, yeah, still it is listed there because this information is still useful. Yeah, so we want to see how many employees who do not have the supervisor. Yeah. All right. So that's the, based on the rule regarding the null value. Okay. Yeah. All right. Yeah, here. Another example, join condition in conjunction with group by. Yeah. 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 Let me look at the time we have. Yeah. All right, 2 minutes. Yeah, 2 minutes. That's enough for our last example today. Yeah. All right. Question. For each project, retrieve the project number, the project name, and the number of employees who work on that project. Okay? Yeah. Work on that project. So now you can see you need to use that project information to define groups, subgroups. Okay, yeah. So look at the query. Select P number, comma, P name, and count the number of tuples in each subgroup, all right, from project, comma, works underscore on, where P number equals P number. No, yeah. And group by project number, comma, P name. Now here, yeah. Although in this example, it tried to show you the joint, try to show you we use 2 attributes to define subgroups, but actually you can see it's not necessary. Why? Because we know P number, project number is a primary key, right? The project number and the project name, that's one-to-one correspondence, right? Can you imagine 2 different projects with the same name? Okay, so that's not good, right? If it's a one-to-one correspondence, why you use 2 attributes, right? Yeah, because it's equivalent to 1 attribute, all right? Yeah, so that could be simplified to the 1 attribute definition, grouping definition. All right, yeah, you can simplify it. Yeah, because two, you basically define the same subgroups as one attribute, right? Yeah, so no difference for this special case, one-to-one relationship. If it's not one-to-one, then it's different. Yeah. Yeah, two different attributes, then so you will have, different subgroup definition. Yeah. All right, yeah, so let me stop here. I have 2 slides left. Yeah, so let's, we continue after the spring break. The next week, it will be spring break.